Welcome to the U.S. Space and Rocket Center in Huntsville, Alabama. I'm Adam Bree, CEO of Skydio, and we're here today to launch 3D Scan. 3D Scan is a breakthrough autonomy software product that makes it possible to capture everything from bridges to accident scenes with incredible precision. 3D Scan makes it easy to fly inspection and mapping missions that would be impossible with any other drone. This is a product we've been working on for the last 18 months, but it's building on over a decade of research and development in autonomous flight. It's at the center of what we love to do at Skydio, build autonomous systems that make drones more useful than ever before. Now, you may be wondering why we're hanging out under a giant rocket to talk about 3D Scan. Well, there's a few reasons. One, rockets are awesome, and at Skydio, we love stuff that flies. Two, we needed some complex 3D structures to show off what 3D Scan is capable of. Most importantly, the early days of the US space program are near and dear to us at Skydio. These are some of the first flying computers that ran software for sensor fusion and navigation. Many of the algorithms that we run on Skydio drones that make Skydio 3D Scan possible have their roots in the software that took the astronauts to the moon over 50 years ago. Skydio, our mission is to make the world more productive, creative, and safe with autonomous flight. And we're incredibly excited to see this vision coming to life today with our customers. We have adventurers creating videos that would be impossible to film any other way. We have first responders using our drones for search and rescue missions. And we have bridge inspectors helping to keep our world's infrastructure safer. The Skydio Autonomy engine makes anyone using one of our drones more capable and more confident. Now, at the center of almost every professional use of drones is some variation of creating a digital copy of the physical world. The data that drones capture can be used to spot problems, track changes over time, create reality models that can be used for all sorts of things. But our world is three-dimensional, and capturing this data can be hard. Whether it's inspecting electrical transmission towers, or bridges, or cell towers, traditional inspection methods usually involve some combination of a lot of heavy machinery and a lot of risk to the people involved. Drones have the potential to get better data while keeping everybody on the ground safer. But it goes beyond just infrastructure inspection. Creating digital twins and 3D models of the real world has the potential to transform industries. Consider first responders trying to document an accident scene. They could spend hours taking pictures manually, making notes, trying to operate a cumbersome laser scanner. Now, the most forward-leaning organizations have figured out how to use drones to help with some of these tasks, but 2D GPS waypoints fail at high-quality 3D capture, and trying to fly a complex 3D scene manually can be excruciating. A big part of the motivation for building 3D Scan was spending our time with customers and seeing what they were trying to do with drones. JIW was one of our first enterprise customers. They do bridge and other infrastructure inspection in Japan. Now, the Skydio Autonomy engine enabled them to fly missions that were previously impossible, but it was still an incredibly complex workflow to inspect a large structure up to their standards. In this picture, you can see a pilot working alongside a civil engineer and a photogrammetry expert. Inspecting a bridge could take days of effort from this team of three, and they can't be sure they've got the right data until they spend even more time post-processing everything. There's no way drones are going to scale to serve all the customers and applications that can benefit from creating digital twins of our world with that much friction involved in doing it. The path forward is more autonomy. 3D Scan builds on the Skydio Autonomy engine. we're taking the next step. We're going from autonomous flight to automated workflows. At the core of 3D Scan is a revolutionary adaptive mapping engine that builds a high-quality 3D model of the structure as the drone flies, and then adaptively uses that model to plan all the right camera angles to guarantee coverage. Whether you want to build a 3D model or you just want the photos, with 3D Scan, you know you're going to get all the right data, and you know it by the time you land. Even the world's best drone pilots be hard-pressed to fly with the kind of precision and patience it takes to capture this data. 3D Scan makes it easy. As with all of our products, the best way to understand it is just to see it in action. So let's scan some rockets. To demonstrate 3D Scan, I'd like to introduce you to Alden Jones, Skydio's Vice President of Customer Success.
Thanks, Adam. Before I get started, I'd like to talk a little bit about my career so I can better explain why I'm so excited about 3D Scan.
I'll leave you to it.
Thanks. Prior to joining Skydio, I started my career as an Army officer, and after transitioning out of the military and into the commercial space, I launched a large UAS program retraining 175 existing employees to become drone pilots. Our objective was to scan 20,000 cell phone towers a year, digitizing the company's more than 40,000 assets. Doing that with manual drones was incredibly challenging. As many of you with drone programs know, each crash or poorly reconstructed model can lead to doubt in your organization, headwinds with funding, or ultimately slow down adoption. Additionally, manual flight or cumbersome GPS-planned missions require an intense commitment to training and often don't meet the expectations of executives who are looking for cost savings and more profit. My job at Skydio is to ensure that when our customers get their products, they can immediately get results. And to show you how easy it is to get those results, today, I'm going to scan the 5 F1 engines on the back of this Saturn V. 3D Scan is designed for maximum adaptability and ease of use. The user only has to complete a few simple steps and the drone will do the rest. The first thing we have to do is get it in the air. Now that the drone is up in the air, the first thing I need to do is set the floor. You can think of the floor as the lowest part of your volume that the drone is going to scan. The next thing I'm going to do is set the ceiling. You can think of the ceiling as the highest part of the volume or the top that the drone is going to scan. Both of these are represented in augmented reality as green and orange planes in the scene. Lastly, I'll set the pillars or the sides of the volume. Once that's done, I'll set the drone into exploration phase. While it's exploring, the drone will use its real-time computing to draw a 3D model of the scene so it can later plan its photogrammetric mission. Now that the drone is exploring, I'd like to take a minute to highlight some of the things that I'm not doing. I'm not climbing a ladder or belaying on a rope. I'm not in a snooper truck or riding in a bucket truck. I'm not putting myself or any of my team in danger in order to accomplish the mission. I'm also not relying on a magnetometer or a GPS. That allows me to fly unconcerned in places like this with overhead cover, next to large metal structures like these rocket engines, or near equipment that emits electromagnetic interference. Lastly, I'm not pre-planning a GPS mission through a painstaking manual process. I'm also not capturing photos manually, hoping that I collect the right data. I'm simply telling Skydio what I want to scan, and the autonomy engine is doing the rest. Now that we've finished the exploration phase, there's a few key parameters that I need to confirm. The first is GSD, or ground sample distance. You can think about that as the size of a pixel represented in real life. The next is overlap. You can think about that as the percentage of two adjacent photos overlapping in the real world. You can crank these both all the way up and get a high-resolution, high-fidelity 3D model with sub-millimeter GSD, or turn it down for a faster photo-only inspection type use case. And then all I have to do is hit go. Now you can see Skydio is autonomously maneuvering between photo locations to execute the mission. All I have to do is monitor its progress and be a visual observer. 3D Scan has two new augmented reality features to help me do that. The first is real-time AR coverage, which shows me which parts of the scene have already been photographed with proper overlap. This allows me to look for blind spots, monitor progress, and ultimately eliminates errors. In our conversations with customers, we've seen up to a 30% reinspection rate for drone service providers not using 3D Scan. The next is AR Observer, which gives me another tool to be aware of my drone's surroundings as it navigates the scene. I simply set a fixed camera position from a given vantage point and get to watch the drone navigate the scene in augmented reality. Lastly, if multiple flights or battery changes are needed, the drone will autonomously return home. The only thing that I have to do is swap the batteries, and 3D Scan makes this seamless and easy. Once I relaunch the drone, it'll resume its mission right where it left off. Leaving a job site after a 3-hour one-way trip, not knowing if you have the proper data for reconstruction, is an unacceptable waste of time and resources. With 3D Scan's augmented reality views, that is no longer a problem. I can't stress this enough. It really is that easy. Whether you're a seasoned professional or brand new to the drone space, you simply follow the inputs in 3D Scan's UI and you'll get the data you need. In the time it takes for you to set up a manual drone and plan a GPS waypoint mission, you could be done with a 3D Scan. There is nothing else like this on the market. It is game-changing tech.
Hike.
Hey, Adam.
While 3D Scan is up there doing its thing, let's learn more about the underlying technology that makes this possible. I'd like to introduce you to Heike Martiros, our Vice President of Autonomy.
Thanks, Adam. So, the autopilot that steered the Saturn V through its 13 missions in space was an engineering marvel of its time. The ring you see behind me is the instrument unit which housed the key sensors that made this possible, like accelerometers and gyroscopes, as well as the launch computer, which weighed 72 pounds and could process 12,000 instructions per second. It was an incredible feat. Well, half a century later, we've made some progress. The primary chip that powers each Skydio drone has many of the same sensors and 100 million times the computing power. Our founders and team have been working for a decade to harness these advancements in computing to bring you the most intelligent and trustworthy autopilot there is. Every Skydio drone uses its 6 navigation cameras to see and understand the world around it, using computer vision and deep neural networks. That's how they're able to duck and dive through obstacles to capture Hollywood-style footage of our customers mountain biking or skiing. And 3D Scan builds on top of this with a groundbreaking AI for inspecting and understanding complex structures. So once you've set up your scan volume, as we saw from Alden, the drone will enter the exploration phase, where it will zip around the structure, and you can watch as it builds up a 3D mesh in real time. And the way it does this is it uses a set of deep neural networks to process all the imagery, and then pass that data to a large nonlinear optimization problem which solves for the exact camera viewpoints and then incrementally updates the mesh. And this mesh is super key because that's how the drone creates the flight plan to capture the perfect data set for any photogrammetry engine. And it does this just like a human pilot would, by studying the scene. So every flight plan is tailor-made to the specific structure you're inspecting. It's not a fixed pattern that's going to miss the important bits or get stuck if there's a tree in the way. Once we have the flight plan, the drone will go into the inspection phase where it will systematically capture every viewpoint with, well, robotic precision. You can imagine the drone is painting all of the mesh with close-up, high-resolution imagery. Even if you're a drone and a photogrammetry pro, it's near impossible to keep track of what you've imaged when we're talking about hours of flying and thousands of photos. With 3D scan, it does it for you without missing a spot. So that's how 3D scan is democratizing the creation of millimeter-scale digital twins of the world. Our incredible team at Skydio is working hard to bring you the state-of-the-art in robotics and AI so that you can just hit go. And as we like to say, nothing flies like a Skydio. Let's get back to Alden and see how that scan went.
Now that our Skydio has autonomously landed on its case, if you leave the drone powered on, you can use your iPhone, iPad, or laptop to view the data we just collected. Our Edge Model Viewer makes it possible to leverage the drone's onboard compute to view a 3D model of the scene you just scanned. Without any LTE connection, I can use this model as a map, selecting areas of interest, like these rocket engines we just scanned. The tool will then pull up all the photos associated with that point in space so I can inspect my job. You can do all of this without removing the SD card or uploading anything to the cloud. In combination with real-time AR coverage, you can be confident that you've captured all the data you need before you leave the job site. Once I'm good with that, I can export my geotagged images to the photogrammetry engine of my choice. Whether I'm handing that data off to a client, an inspection crew, or a jury, they can have confidence that they have the data they need. We've worked with the leaders in data processing software to ensure that we get good results when uploading 3D scan data to Bentley Context Capture, Drone Deploy, or Reality Capture. But really, you can upload 3D scan data to any photogrammetry engine. Here's an example from the US Space and Rocket Center that we just scanned from our partners at Bentley.
What really matters is how all of this comes together for customers. So here to help us understand how 3D Scan is already solving real-world problems is Dean Miller from Sunt Construction. Dean, thanks for joining us here. Can you start off by telling us a little bit about Sunt and the work that you do there?
Yeah, absolutely. Thanks for having me, Adam. Sunt Construction is one of the largest 100% employee-owned construction companies in the U.S. We specialize in transportation, industrial projects, commercial building, renewable energy, and concrete. I'm a virtual design and construction engineer, and I'm also the Enterprise Drone Program Manager.
So Sunt has built a reputation as having one of the best enterprise drone programs in the world. How did you get started and where are you today?
We started in 2013 with the DJI Phantom 2. Our worker would go out to the job site and he would take pictures and videos with his drones, and oftentimes his coworkers would tell him to get back to work and to stop playing with this toy. But the drone program has grown, and now we're at 25 to 30 pilots with our program, and we use them for 3 distinct phases of construction: business development, operations, and closeout. With business development, when Sunt decides to pursue a project, we'll send a pilot like myself out and we'll fly and create an orthomosaic map and a 3D model. This helps us get a better estimate of the bid of the work we're going to do. During operations, we use that orthomosaic map to verify accuracy of underground utilities, and we use the model for our BIM coordination as well. With closeout of a project, we fly our thermal drone and capture the facade of the building or the equipment to check for energy loss. And we are taking 2021 to transition from manual drones over to Skydio autonomous drones.
That's great to hear. We're really excited and thankful to have Sunt as a customer. It's an interesting common theme there that oftentimes enterprise drone programs start with just a hobbyist bringing one to work to play with it. You guys have been amazing beta testers of 3D Scan. Can you talk us through some of the work that you've done so far?
Yeah, absolutely. Sunt has taken the opportunity with Skydio 3D Scan to create very detailed 3D models of equipment that we have out in the field. You know, with the construction industry as a whole, the work-related injuries have gone down, which is good, but work-related deaths have stayed the same. This is something that Sunt is looking to fix. Traditionally, we're getting these models using a laser scanner and a team of 2 guys, and we'd have to go out and we'd have to shut down the equipment and clear the job site and put these guys in a potentially hazardous situation. And not to mention we're in Arizona where it gets really hot really fast. We send our laser scanners out, and it takes hours, and we're constantly fighting with the heat of the day and the equipment malfunctioning. So to overcome this, we're using that Skydio to create these really detailed models, and it puts a drone in the place of these people, and we can effectively save somebody's life by not having them in that situation.
It's pretty amazing to hear about the life-saving potential of drones. The other day you were showing me one of the 3D models that you generated with 3D scan. It's pretty amazing stuff. Maybe we could look at that now and you could talk us through it.
Yeah, absolutely. This is a crystallizer water cooling tower from a semiconductor facility that we have in Chandler, Arizona. It takes superheated water and it cools it all the way down to 200 degrees, which is still boiling, but it's much cooler than what it comes in at. This model was very easy to generate. It took me 30 minutes, and I didn't have to shut down any equipment, costing in time and labor, and I didn't have to clear anybody out of the job site to do it.
Yeah, that's a pretty amazing result. Can you talk to us about the kind of impact you see 3D scan having going forward?
3 things come to mind moving forward, and that's faster, better, and safer. We can create these 3D models in a high amount of detail much faster than traditional means, and it also reduces the amount of rework we have to do, effectively saving 9% on our overall budget. Better, we're creating these incredible 3D models that we can just use for the Skydio can go and get these. And safer, we're not having to put those people in inherently dangerous situations.
Well, look, thanks for all the pioneering work that you're doing with this. We're looking forward to working with you to hopefully keep your construction sites safer and scaling around the world. Thanks, Dean.
Us as well.
We'd like to extend a few thank yous. First, our launch partners. It's been great working with you to integrate 3D scan into processing workflows. Second, the Space and Rocket Center. It's an inspiration being here with these iconic spacecraft. Skydio will be donating a fleet of drones to the Rocket Center's youth education programs. We look forward to working with you to help educate the next generation of aerospace engineers. Third, the Skydio team. Congratulations to everyone who made this product possible. We've accomplished a lot, but we're just getting started. Finally, Skydio customers. Those in the early access program, and especially those who are already adopting 3D scan. It's hugely motivating to see the results that you're generating. We plan to keep the features and capabilities coming. If you think 3D scan can be useful for you, you can learn more and contact sales at skydio.com/3dscan. When you're ready to add it to your program, Alden's team will work with you at every step of the way to make sure you're successful. 3D scan is available now. We can't wait to see what you do with it.